I taught my lesson for on how many tens there are in three-digit numbers for a student who is struggling with place value. For the first worksheet we used in the problem, the student was easily able to find how many groups of tens there were in the numbers 320 and 650. Here she drew out the outlines of base 10 blocks to find her answers. For the second worksheet, the question was a little bit more difficult. It was, the students in Mr. Smith's class are collecting pennies. They decide to display them in stacks of 10. How many stacks can they make with 356 pennies? How many single pennies will they have left? Here the student was able to note that 300 makes 30 tens, as she drew here, and then the 50, but instead of counting the 6 ones, she made another group of 10. Well, first she had here 41 groups of 10 because she just took the 30 and added 5 and 6, and then she realized that that didn't make any sense. So then she came up with the number 36 because she had the 30 tens from 300 and then the 5 tens from 50. And then she just added, instead of doing the 6, she just made this another 10 to get 36 tens in total. The student made the same issue in this problem when she had to find how many groups of 10 there were in the number 468. She was able to get the 40 tens in 400 and the 6 tens in 60, but instead of realizing that 8 here would just be the number left over, she just counted that as another group of 10 to get 47 tens total. And then we revisited the problems again with the student, but use this place value chart and base 10 blocks. I showed the student how 1 unit would be 10 of these, which would be 110, and these would count just as ones. And then 10 of these would make hundreds. And so we put the numbers out together, and she realized that for this problem, this could not be another group of 10 because it was only 8 single ones. And she did the same thing for this problem. She realized that it would make 35 groups of 10, and then there would be 6 left over because that it can't be a group of 10 because there's still 4 missing, so it just has to be single units. I wanted to make sure that the student was able to see the numbers visually, so that's why I brought out the base 10 blocks, and I feel that they were super helpful because she was able to see that this would be one group of 10, and that there's no way that this could be a group of 10 because it does not look like this. And it was very helpful for when she was looking at the other numbers in the first problems. In our textbook, Elementary and Middle School Mathematics, on page 90, Van de Waal states that we should have a variety of materials available for the student, so that I made sure she had paper and pencil, whiteboard and markers, and then the base 10 blocks and a place value chart. For this student, I basically did a formative assessment. I observed her as she completed the 2 problems on her own and identified her misconception of place value and addressed the misconception and completed the problem again with her using the base 10 blocks so she had a better understanding of how to solve it. As stated in our textbook, formative assessments dramatically increase the speed and amount of student learning. I used the student's results and evidence to improve the instruction. I also made sure the student could explain to me how she received the answer the second time so I knew that she actually understood what was going on. In our textbook, Van de Waal also states that a significant challenge when using the pre-grouped physical models occurs when students have not had adequate experience with groupable models first. This is where the potential for students to use them without reflecting on the 10-to-1 relationships, and I feel that this is what happened to this student during this problem. Thanks for watching.